Hello, welcome to another edition of the Henstitute. This one is also going to be on curved mirrors, but this time we have what is called a convex mirror. So this one, if you notice, is actually sloped outward. So the focal point, over here, and the center of curvature, are on the opposite side of the mirror from the actual object. So this is our object over here, this little arrow that I've drawn, and the focal point and the center on the opposite side. They've written a couple of stuff out so that we've got F and we've got R here, R being basically the distance from the curvature of your mirror, and the center showing that it's a radius as you're dealing with it. So a couple of things still follow that we did before. If I have a ray of light leave the tip of my object here, like I see, this ray of light is leaving here, and it hits this mirror. What we had before, if it happens to be parallel to this axis of symmetry, so this is our axis of symmetry here, that it would actually get reflected through the focal point. But in this case, since the focal point's on the opposite side of the mirror, it can't actually do that. So instead, what we do is we imagine putting a ruler down on top of everything, and this ruler is actually going to go from the focal point away through the mirror. So this little dotted line that we've drawn here is what it would look like if it was on the opposite side of the mirror. And then by the time you get to the mirror, basically this is actually the reflected ray of light that's happening here. So that's one ray of light that we can actually use. So it's still following the same rule as we had before. A ray of light coming in parallel to the axis of symmetry gets reflected through the focal point, but actually reflected away from the focal point. That's why this type of mirror is sometimes also referred to as a diverging mirror, meaning that it diverges the light. The other possibility that we had before is your ray of The other possibility we had is a ray of light could go through the focal point and it bounces off of the mirror parallel to this axis of symmetry. Well, again, since our focal point is on the opposite side, what we're going to do is we're going to imagine laying down a ruler so that it goes from the tip of your object to where the focal point would be. So if I were to draw this, this is what the line would look like. It's going to hit the mirror there, but if I were to draw little dotted lines here, they eventually go through the focus. I'm attempting to use a ruler here, but it's not going to be perfect. So the idea is that initial ray of light, that's going to be our incident ray, is going to strike that mirror. Now, if it were to continue, it would go through the focal point, but it can't. So instead, after hitting that, it's going to come off parallel to my axis of symmetry here. So it's going to come off parallel to this. So it's going to travel in this particular direction. And this would be our reflected ray. Looking at this reflected ray and this reflected ray, one of the things I notice is they are diverging. They are not going to cross. And so I am not going to have those rays of light cross on the same side as my object over here. And most people would look at this and say, oh, it's not going to produce an image. But that is not actually the case. Instead, what we have to do is we have to look at the rays of light that go on the opposite side of the mirror. But you have to take the ones that are the reflected rays. So for example, this is our reflected ray. What I'm going to do is I'm going to look at the part that goes back. So these little dotted lines, they go back to the focal point. So it's like it's coming from the focal point. So this is still part of the reflected ray. And then I'm going to do the same over here. I'm going to erase these little dotted lines because I don't want these to kind of confuse you here. If I can get them to actually erase. that was kind of taking into account that our incident ray was trying to go through the focal point. But what I want to look at is actually the reflected ray. So I'm going to take this one. This is our reflected ray here. And I want to follow it back. So it's going to be horizontal like this. It's going to be parallel to my axis of symmetry. And what I notice is they cross somewhere about there. And this would be the tip of my image. I'm going to continue to kind of draw my other stuff the way I normally would, which is to have it go down to the axis of symmetry. And we could have that. I could also draw another one that goes from the tip of this arrow and goes through the center of curvature and comes back. But that would just be a single line. And what we would find is if I went from here, I would cross right there. Now, this image is very important. This is a image that is right side up. So it's in the same orientation as the original object. It is smaller than the original one, so I can see if I base it on the size, I can actually see that. And it happens to be what we refer to as a virtual image. And virtual just means that it's where the rays of light appear to be coming from. They're not actually coming from that. So we're using the reflected rays, but they're not going to cross over here. So instead, we use what they would appear to be coming from, and that's what creates this virtual image. You can create all kinds of images, right side up, smaller, larger, same size, virtual, real, with all kinds of different mirrors. I'm going to show you a couple of things with concave mirrors that are kind of neat, and convex mirrors, and that's going to finish out this portion of the reflection part of the Henstitute. Hope you enjoyed.